hemophilia in one population is 1 out of every 50, let's say it's very common in this population, 1 out of every 50 males is affected with hemophilia, which is an X-linked recessive disorder. What is the likelihood that a female would be affected? Excuse me. Hemophilia is an X-linked recessive disorder. If 1 out of every 50 males are affected, what's the likelihood that you get a female that is affected? 1 out of 2,500. Why? Because if it's a male that is affected, all you need is one X with hemophilia and the Y. For the female to be affected, you need a little h and a little h. 150 squared. Because she has to have 2 X's. Right? Another style of questions would be, and I'll finish with one more, which would be the hardest, sort of. The frequency of albinism in one population is 1 over 1 over 10,000. Let's make it easy. 1 out of every 10,000 in a particular population are albinos. What is the frequency of carriers? Or in fact, let's make it easy first. 1 out of every 10,000 are albinos. What's the frequency of albinism in that population? If 1 out of every 10,000 are albinos, what's the frequency of the albino allele in that population? Sorry? You do what? You take 1 over 10,000 and do what with it? You square root it. 1 out of 10 to the 4, right, is albino. So that is a little. These are the albinos. So the A is what? A is root 1 over 10 to the 4, which is 1 over 10 squared. 1 out of every 100 is going to be the frequency of the allele. So now, what's the frequency of heterozygotes? You take little a, you calculate big A, you multiply them, and then do what? And times it by 2, because it's 2pq, right? 2pq. This is p, or q, whatever we want to put. A big would be 1 minus this, and you times it by 2. Let me ask you one more question, and then we'll, at least I'll, IB is 0.3.